Welcome to video 7 into my series of Microsoft Fabric DP-700. In this video I will look at event streams and event houses. So event streams. An event stream is a flow of data that arrives continuously in real time. Instead of waiting for files to be uploaded in batches, the data comes in as it happens. Examples include website clicks, IoT sensor data, or application logs. In Fabric, event streams capture this constant flow so you can process and analyze it straight away. Event houses. An event house is Microsoft Fabric's place for storing and analyzing real-time data. It is built on Azure Data Explorer, which is a proven technology for handling time series and log data. Event house is designed for scenarios where time matters, such as looking at the last 5 minutes, hour, or day. It automatically organizes and indexes data by time, making time-based queries very fast. You can use an event house when you need to make sense of streaming data quickly. So how to use event house, how event house stores data. When you create an event house in Fabric, it sets up a custom database in the background. The data is automatically indexed by time, so it is very fast to run queries such as show me the last 1 hour of activity. Even on very large datasets, it can run queries very fast. You can ingest data into an event house using the following: event streams, which are for continuous real-time data, Spark, for processing and loading large datasets, or connectors such as IoT Hub or Event Hubs, which capture telemetry and event data from devices or apps. Custom Query Language, KQL overview. An event house uses KQL, which looks similar to SQL but is designed for events and time series. You should recognize common commands and know their purpose for the DP-700 exam. For example, where, which filters data; summarize, which calculates averages, counts, and totals; bin, which groups events into fixed time intervals; top, which returns the top n rows, the top number of rows; project, which selects specific columns; and extend, which creates new calculated columns. So I'll go over a few examples. So in the example, I will show you the SQL version, if you're familiar with it, and then the KQL version. So this example returns every row from a table. So in SQL, that is select all from a table named storm events. In KQL, you just write storm events. In example 2, we are looking at filtering rows. So this example returns every row from the table with a filter applied. In SQL, it is similarly select all from storm events, where, and then the filter would be wind speed is greater than 70. In KQL, you have this pipe symbol or pipe character. So you'd have storm events again, and then you have the pipe character where wind speed is greater than 70. For selecting columns, this example selects specific columns. So SQL uses select, while KQL uses project. So in SQL, that is select event ID, wind speed from storm events. So those are the two columns we're selecting, event ID and wind speed. And in KQL, you write storm events, pipe character, and then project, and then the two columns. For aggregations, this example calculates the average wind speed for the last hour. So SQL uses AVG to calculate the average, where with a time filter, and KQL uses summarize as well with AVG. So the first one is SQL, that is select average of the column from table storm events, where the timestamp and then the filter for the timestamp. Whereas in KQL, you have storm events, table name, and then you'd have the where first. So you have where timestamp is greater than 1 hour ago, and then you have summarize, average wind speed equals AVG, and then open brackets, column name. And for the last example, this query finds the top 10 most common error types. It counts how many times each error appears and then sorts them so the most frequent errors come first. In SQL, you can see it is doing select two columns, and the last column is a count from a table named app logs. It is then having a where filter, where level equals error, grouping them by error type, order by count in descending, and then limiting this to 10 rows. In KQL, we do app logs, which is the table. Then you have the where. Note it is a double equals as well. Summarize, and then you're making a column called count, which equals count by error type. And then instead of limit 10, you're using top 10 by count descending. So when do you use an event house? So an event house is best suited for IoT, telemetry, monitoring thousands of sensors, application logs, analyzing performance on errors, security monitoring, detecting unusual patterns, and real-time dashboards feeding live data into Power BI. Event streams capture real-time data from many sources. They can route events to destinations such as an event house for real-time analysis, a lake house for storage and batch processing, or a warehouse for structured analysis. So the key takeaways from this is that event streams capture and move real-time data into Fabric. Event houses store and query this data for analysis. They are ideal for streaming, time series queries, and live dashboards. We'll now look at some questions. So question 1. Which Fabric component is built on Azure Data Explorer and designed for time series data? A lakehouse, an event house, a warehouse, or a data mart? The answer is an event house. An event house runs on Azure Data Explorer and is optimized for real-time time series analytics. A lakehouse is for batch big data, not real-time. A warehouse is for structured SQL queries, and a data mart is for self-service BI, not logs. Question 2. What is the role of event streams in Fabric? To batch load CSV files, to store real-time IoT data, to capture and route real-time data, or to generate Power BI models? And the answer is to capture and route real-time data. So, to capture and route real-time data, this is streams ingest live events and sends them to Fabric destination. Batch CSV loads, that's batch, not streaming. For store IoT data, that storage is done in Eventhouse, not streams. And generate Power BI models, that's data flows or data marts. Question 3. Which query language is used in Eventhouse? SQL, Python, KQL, and DAX. And the answer to that is, of course, KQL. So, event houses use Kusto query language, or KQL, for logs and time series. SQL is used in Warehouse, Python is for Spark notebooks, and DAX is for Power BI models. Question 4. What makes Eventhouse fast for time-based queries? A. It stores data only in CSV files. B. It uses auto-indexing by time. C. It pre-aggregates all values. Or D. It runs only on small datasets. And the answer is B. It uses auto-indexing by time. Data is indexed by a timestamp, so time filter runs efficiently. CSV only is not correct as it is too slow for analytics. Pre-aggregation is not correct. It is not how Eventhouse works, and small datasets is not correct either. Question 5. Which Fabric component provides a no-code way for business users to ingest data and instantly create a semantic model? A. A lakehouse. B. Eventhouse. C. Warehouse. Or D. Data mart. And the answer is Data mart. Data mart provides a no-code experience where business users can load data and get an auto-generated semantic model for Power BI. A lakehouse requires Spark for transformation, so not low code. An Eventhouse is for real-time and time series data, not semantic models. And a warehouse uses T-SQL, so not low code. Thank you for watching, and that is the end of this video.